talk about circle equations. First, we need to define what a circle is. So a circle is a conic section. A conic section is a plane figure formed by the intersection of a double right cone and a plane. Now, at first glance, that definition seems perhaps a bit technical, but if you take a look at this figure, you see that we have a double cone, right? So cones resting tip to tip, and you can see that that orange plane, which is cutting through the cone horizontally here, is creating our conic section. So imagine you had this figure, this double cone in front of you. You sliced into it just exactly where this plane is slicing into it. If you looked down on top of it and you looked straight down at your cut, you would see that the impression left over would be in the shape of a circle. That's how conic sections are formed, by having this plane intersect at different angles. You can see how tilting the cut would give us a different shape based on depth or degree of the cut. We get 4 different conic sections, but today we're just talking about circles. Further on circles, let's also remember that a circle is a set of points in a plane that are a fixed distance from a point, usually known as the center. Now, imagine you were trying to describe a circle to your friend over the phone, and your friend's never seen a circle. How would you describe it? What vocabulary would you use to describe this shape? Thinking of it in that context, we could say, well, someone who has no knowledge of what a circle is would be able to draw one if we told them this. A circle has a center point. And you could direct someone to draw a point at a location that you specify. So normally, if we're working on a grid, you would be given XY coordinates of this center. Great. Now if you defined a radius, which is a fixed distance of some unit, for example, let's say we have a radius of 2 units. If I told someone to draw the radius and graph a point at the end of the radius, so if my radius is 2 units, 1, 2, graph a point at the end of the radius, and if I did this in every single direction away from the center point, I would end up with, well, first of all, I would have a bunch of points, right? Infinitely many points. But you can see that how eventually, graphing all these points that are exactly 2 units away from the center begins to roughly form the shape of a circle. And again, if we did this infinitely many times, it would appear as a bold definition here of a circle. So it's important for us to recognize that to define a circle, all we needed was a center point and a radius. All we need to define a circle is a center point and a radius. So the equation of the circle, as you can guess, if that's all we need to define it, then that's what's in the equation. So equation given here describes a general circle. You see x minus h squared plus y minus k squared equals r squared. R, as you can guess, is your radius. H is the x-coordinate of the center. And k is the y-coordinate of the center. Okay? So we have x minus h, the x-coordinate of the center, y minus k, the y-coordinate of the center, and then r. And that's all we need to define any circle. So, let's practice. Let's say we have a circle with center 3, -4, and a radius of 2. My first step is always to write out the skeleton of the equation, meaning I know that any circle is going to have this loose formation. Even if I know nothing else, I can write out that much of the equation. They've given me the center. They've told me the x-coordinate of the center is 3. They've told me the y-coordinate of the center is -4. And they've told me that the radius is 2. You can see I've just filled in my numbers. Now I simplify. I leave x minus 3 squared alone. Notice that because I'm subtracting a -4, this becomes y plus 4 squared. And I'm going to leave the 2 squared as it is. The The reason I'm doing that is I want to be able to quickly glance at my equation and identify 2 as the radius. So in the end, my equation for this circle with a center at 3, -4, and a radius 2 is the quantity x minus 3 squared plus the quantity y plus 4 squared equals 2 squared. Let's keep practicing. All right. If I have a circle with center for 4 and radius 4, what's it going to look like? Start by writing out the skeleton of the equation. My x-coordinate goes here, my y-coordinate goes here, my radius goes here. And this is perfectly acceptable in the form that it's written in. Again, I like to leave the radius written as r squared because it helps me quickly identify that 4 is my radius. If I were to carry out this exponent and write it as 16, you might mistakenly think that 16 is the radius, when in fact it is not. All right, let's keep practicing. Before I even glance at this one, I'm going to write out the skeleton of my equation here. Now I'll get to work matching my pieces. My x-coordinate is 0. My y-coordinate is -6. My radius is 1. Rewriting this simplified, well, x minus 0 is just x, so I can write this as x squared plus y minus a -3 is y plus 6 squared equals, and then 1. I could write it just like this, or I could add the squared. It's an equivalent expression either way. There's my equation for this circle. So you can see when you are given the center and you are given the radius, it's very easy just to fill in the information. Let's move forward. Let's move on to the distance formula. So the distance formula comes in handy if you know the center but you don't know the radius. So the distance formula helps us find the radius. If you're taking notes, that'd be a good thing to write down. Distance formula helps us find the radius. Okay. So the distance formula is based on, let's say you have this point, I'll call it point 1, and I want to know the distance between point 1 and point 2. Now, it would be ideal if I could just measure on a diagonal here and tell you the length, but we can't do that, right? Because the way we work when we have our x and y axis is that we can only count up or down or left or right. Diagonal doesn't work. So what I can do instead is say, okay, how much lower is point 2 than point 1? I can measure that. How much lower is it? What's the change in y? I can also ask myself, how far to the right is point 2 versus point 1? How much did it move in the x direction? Now, if you consider this picture that I've drawn, hopefully you can see where I'm going with this. If I have a right triangle, and I know 2 of the lengths, I can solve for the third one using the Pythagorean theorem. That's what the distance formula is based off of. Notice that, just like here where I measured the difference in my x distances, that's what's happening here. It's taking one x-coordinate and comparing it to another x-coordinate. If you look at our y-coordinates, just as I did here, I asked myself, how much higher is point 1 than point 2? That same question is being answered right here. So you can think of this as kind of a different version of the Pythagorean theorem, and it's going to tell us the length of the radius. So how is that telling us the length of the radius? How do we go from one thing to the next? Well, what if you were told the center of a circle? Say we had this circle. You were told the center and you were told the coordinates of some point on the circle. If you knew the distance between these, if you knew this distance, well, isn't that equal to the radius? Because isn't any point on the circle equally distant from the center? So that's what's happening here. We're told a center coordinate, we're told a point on the circle. We have to write this, we have to fill in this circle equation, but first we have to know the radius. So let's fill in our information, starting by solving for radius. Okay. Now I like to, as a convention, always assign the center coordinate to x1, y1. Always assign the center coordinate to x1, y1. Now, if I do that, I get something that looks like this. My x-coordinate, so I'm setting up my skeleton. I'll write in my x-coordinate, which is negative 4. My y-coordinate is 11. Now I fill in my other coordinate. Now, whereas before we stopped here, right, because we had an x and a y, and that just gave us our equation. Remember, in this case, we're actually solving for radius, so we have to continue forward. So the x-coordinate of x2 is 5, and the y-coordinate is negative 1. I have this equation set up, and now all I have to do is continue to simplify it in order to solve for radius. So what's 5 minus a negative 4? It's 9. And what's negative 1 minus 11? It's 12. Keep simplifying. So 9 squared is 81, and negative 12 squared is 144. 81 plus 144 gives me, what does that give me? 225. So I have the root 225, and root 225 is equal to 15. So my radius is equal to 15. Notice that I know I'm only taking the positive root, right? It's not plus or minus 15, it's just positive 15, because radius is a distance, and we can't have negative distances. So great, I just found that my radius is 15, but I'm not done yet because I need to write the equation for this circle. So I go back to just as how I was doing this before, writing out the skeleton of my equation. Good thing I figured out my radius, so I can write that in right away. Now I reuse my center coordinate. I put my x coordinate of the center, my y coordinate of the center, and now I'll just simplify. I'll clean this up. So x minus a negative 4 is x plus 4. Y minus 11 squared equals 15 squared. Again, leaving 15 alone so that it's easy for us to recognize the radius. Let's practice again. Okay, so this time we have a center of negative 1, 0, and a point on a circle 2, 5. Let's fill in our information. Again, starting out by writing the skeleton of the problem. Let's see what we come up with. My center is going to be x1, y1. So I put a negative 1, my x-coordinate, 0, my y-coordinate. Keep going. 2 is x2, 5 is y2. Now it's a matter of simplifying and solving for r. 2 minus a negative 1 is 3, so I've got 3 squared. 5 minus 0 is simply 5, equals r. Continuing on, 9 plus 25 equals 34. So my radius is equal to the square root of 34. That's fine. Don't always expect these to come out as pretty whole numbers. Cool, so I have my radius. Now let's write in the information into the equation. So I write my skeleton, x minus something squared plus y minus something squared equals something squared. I know that my radius is root 34, so I put root 34. The x-coordinate of the center is negative 1, the y-coordinate is 0. Simplifying, I would rewrite this as x plus 1 squared plus y minus 0 is y, so y squared equals, and then this is a case where I might rewrite this as 34, only because it's a bit odd to leave it in this form, the square root of 34 squared, but that's a judgment call. So either form of 34 is correct here. And there's my equation of the circle. Let's do one final practice. All right, so I've got my center coordinate. I've got the point contained on the circle. So, write out my framework first. Remember that my center, HK, is also going to be x1, y1. The x-coordinate of my center is 1. The y-coordinate of my center is 2. The x-coordinate of the other second coordinate, so x2, y2, is negative 4, and then I've got 9. Simplifying from here, negative 4 minus 1 is negative 5. 9 minus 2 is 49. or excuse me, is 7. I was already squaring it in my head, so I get 7 squared equals r. Now I get my 49. So I have got 5 squared equals 25, and 7 squared is 49. Continuing forward, 25 plus 49 would be 74. So the root 74 is equal to my radius. Great. Let's plug this in. So x minus something squared, y minus something squared is equal to something squared. All right, so the x-coordinate of the center is 1, the y-coordinate is 2, and my radius is square root 74. Again, if you chose to rewrite this as a radius of just 74, so the radius squared is equal to 74, that's fine. But if you look at this and you know that you're going to look at this and think, oh, 74 is the radius, don't write it this way. Just leave it this uglier way, root 74 squared. More important that you understand the information that you're writing than it's as concise as it could be. Okay, so that is how to use the distance formula to solve for radius in order to write the equation of a circle given a center and a point on the circle.